So we've learned how to graph a quadratic function in vertex form and factored form. So the last form we need to learn how to graph is standard form. So maybe you remember seeing this when we were factoring. Standard form is y equals ax squared plus bx plus c. To find the axis of symmetry from standard form, we use x equals the opposite of b over 2a. You might recognize this as part of the quadratic formula. It's the very first part and the denominator, so it just doesn't include that square root part. So of course, like factored form, to find the vertex, once you know the axis of symmetry, you substitute that value back into the equation to solve for y. So today all we're going to practice is how to find the vertex from standard form, and then tomorrow we'll look at how to put everything together on a graph. So as I mentioned, the first thing we find is that axis of symmetry. As a reminder, notice that I am labeling my work and I would like you to do the same. So the axis of symmetry is an equation x equals, make sure you've got that x equals, identifying our a as the coefficient of x squared. If you don't see anything that you're multiplying by 1. B is the coefficient of x, and c is our constant. For the axis of symmetry, we just need b and a. So it's the opposite of b over 2a. So negative 10 divided by 2, we multiply in that denominator before we divide, and that gives us negative 5 for the x-coordinate of our vertex. So then we take that value, substitute it back into the equation to find the y-coordinate of our vertex. So we have y equals, substituting in that negative 5 for x, plus 10 times negative 5 plus 3. Order of operations, we'll square the negative 5. Remember, when you multiply a negative by a negative, it becomes positive. We can also multiply the 10 and the negative 5. A positive times a negative is negative. And then we'll combine all of our numbers. 25 minus 50 is negative 25, plus 3 is negative 22. Writing our vertex as an ordered pair, we had an x value of negative 5, and we solved and got a y value of negative 22. The last piece we need to graph a quadratic function in standard form is the y-intercept. Remember, the y-intercept occurs when x equals 0. So we take all of our x's and replace them with zeros. Of course, 0 squared is 0, and 10 times 0 is 0, and 0 plus 3 is 3. So we get a y-intercept of 0 for our x value, and we got 3 for our y value. Next example, first I'm going to identify my a, b, and c. Remember, a is the coefficient of x squared, so what we're multiplying the x squared by in this case is a negative, and of course negative isn't a number, so it's negative 1. B is what we're multiplying by the x, which is negative 6 in this case, and c is the constant. It's the number that's not being multiplied by a variable, so we have negative 1. Finding our axis of symmetry, again, I am labeling my work. X equals the opposite of b. In this case, our b is negative, so the opposite of negative 6 is 6, divided by 2 times a. Multiplying the 2 by negative 1 and then dividing, we get negative 3. To solve for our vertex, we're going to take that value and substitute it back into our equation for x. Now be careful on this one that you don't violate order of operations when you're substituting that negative back in for x. The negative in front of the x squared needs to stay there, and we have to square the negative 3 before we multiply it by that negative 1 that we identified as our a value. So as I mentioned, we're going to square our negative 3 first, which becomes a positive 9. Negative 6 times negative 3 is a positive 18, minus our c value, which was 1. Negative 9 plus 18 is 9, minus 1 is 8. So our vertex, we had an x value of negative 3, and we solved to get a y value of 8. Finally, we'll solve for our y-intercept. Again, I'm labeling my work. So we substitute 0 everywhere there's an x, minus 1. So we have 0 squared is 0, minus 0 is 0, minus 1 is negative 1. So we have a y-intercept of 0 for our x value and negative 1 for our y value. Now that we've seen a couple of examples for our y-intercept substituting the value in for x, you may have noticed that our y-intercept is our c value. So up here, we identified our c value as -1, and we got -1 for our y-intercept. On our first example, we identified our c value as 3, and we got our y-intercept as 3. The reason that works is because the other two pieces have a variable, and as soon as you multiply by 0, those pieces go away, so only the c value will be left. So when we look at our last example, I'll show you the shortcut for getting our y-intercept in standard form. All right, starting off by identifying our a, b, and c values. A is what we're multiplying by the x squared, in this case -3. B is what we're multiplying by the x, which is 12. And c is the constant, the number that doesn't have a variable, so we've got -8. Finding our axis of symmetry first, we take x equals the opposite of b divided by 2 times a, -12 divided by -6 equals a +2. Once we have that axis of symmetry, we substitute it back in to get our vertex, again labeling all of our work. So we get y equals -3, substituting in that 2 for x, plus 12 times 2 minus 8. Order of operations, we will square the 2 before we multiply it by the -3. 12 times 2 is 24. Next up, -3 times 4 is -12. And then combining all of our terms together, we get -12 plus 24 is 12. 12 minus 8 is 4. So our vertex, we substituted 2 in for x and solved to get 4 for y. And here's the shortcut for our y-intercept. All we have to do is identify that c value. So our x-coordinate would be 0, and our c value was -8. So we have a y-intercept of 0, -8. Last example, we have to take a look at how this works with a fraction as well. So identifying our a, b, and c values. Our a is the coefficient of x squared, which is 1/2. b is what we're multiplying by the x, the coefficient of x is -2. And c is our constant, the number that's all by itself. So we take a and b to find our axis of symmetry. So we have x equals the opposite of b, again turns that -2 to a positive, divided by 2 times a. 2 times 1/2 is 1, so we get an axis of symmetry of x equals 2. Substituting that x value back in to find our vertex, we have y equals 1/2 times 2 squared minus 2 times 2 plus 9. Squaring our 2 before we multiply, we get 4. Minus 2 times 2 is 4 plus the 9. Half of 4 is 2 minus 4 plus 9. 2 minus 4 is -2, plus 9 is 7. So we have a vertex of 2 for our x-coordinate, and we solved and got 7 for y. And finally, that y-intercept, that shortcut is nice. We substitute 0 for x, and we would get our c value for y, which is 9. Here's your U-Try question. Please attempt this before you come to class so that we can have a productive start to our day.